All right, we are going to talk about section 5.5, graphing cube root functions, another section of graphing here. Cube root functions are a lot different than square root functions. Remember, square root is asking you what number squared gives the number underneath of the root. Cube root is asking you what number cubed gives you the number under the root. The big difference here is that you can take the cube root of a negative number. In the real number system, you can't take the square root of a negative number, or that's at least nonsensical. So with a cube root, we have much different graphs than we do with square roots. You'll remember that square root graphs do something like this, typically. They go off in one direction or the other. You can flip them upside down if you want, but that's not true for cube root functions. So let's look at these for a little bit here. Cube root function is a radical function. That just means it's a root. It's got a root in it. You can see right here. That contains the cube root of a variable. That's cube root function. All right. Cube root function has an inflection point, a point in the curve where the curvature changes direction. It's also called the concavity changing direction, or changing in the concavity. But essentially, an inflection point is where the curve changes directions, and we'll analyze that here in a second. So, in general, we're going to look at the parent function of the cube root function. The parent function is the simplest function of the family. For cube root functions, it's just cube root of x, and this is what it looks like. It's sort of like a sideways cubic. In fact, the inverse of a cubic function, a third power function, is a cube root function. And so you can see that if we look at this graph is going to go forever to the left and forever to the right, and it's actually going to go up and down forever as well. So this one has a domain of all real numbers, and it has a range of all real numbers as well. All right, now the book uses interval notation here, and it uses inequality notation here, but I think all real numbers is fine for your answer. The x and y intercepts are through the origin. The symmetry is about the origin. Not so super worried about that. There's no maximums or minimums. There's no extrema. You can see the end behavior here, and the inflection point here is at 0, 0. So at 0, 0, you can see we have a change in the curvature. So you can see right here, it would almost like hold water. Over here, it would almost, like water would almost kind of fall off of it. So you kind of see that there's a fundamental difference in curvature to the left and to the right of that inflection point, okay? So let's hop over to number 1. Find the domain and range, end behavior, and inflection point of the given function here, cube root of x minus 2. Now, I've given you the graph, but I want to show you in Desmos and also in your graphing calculator how to get the cube root. What you're going to do is you're going to tap functions, or click it if you're on the computer. You tap functions, go over to miscellaneous, and then right here you'll see this n root. You can pick whatever root you want. We'll just want the third root, cubed root, and then underneath you just type what you want in the function. So x minus 2. You can see that's the curve that we get. This must be a negative here. I just didn't type in the negative. Yeah. Yeah, that should be a negative. Anyway, so there you go. That's how you get the cube root there. For the cube root in a graphing calculator, what you're going to do is hit the math key. So you'll tap math, and then you'll see right there is the third root key or command, and then you can type your function and you can put that in y equals and then graph your cube root functions that way. Okay? So we've already got the graph of this. Let's analyze everything. The domain is going to be all real numbers. No question. It's going to go forever to the left and to the right. The range, same thing. Now, you might look at this graph and be like, well, this value right here is not in the range, right? There's no graph there, but this graph is going to continue going down, both in the leftward direction and the rightward direction. Okay, so range is all real numbers. End behavior. So the end behavior is going to be as x goes to the right, as x goes to positive infinity, where does y go? Well, y goes to, so as we track this graph to the right, the y values are going down. So it's approaching negative infinity. And then as x goes to the left, as x approaches negative infinity, y is approaching positive infinity, right? Because as you move to the left, the graph is going up. The y values are getting greater, all right? Where's the inflection point? It's going to be right here. That's where that graph turns. So the inflection point is at 2, 0. Okay? All right, cool. Let's move on to transformations of cube root functions. So in general, what do these values do? A, h, and k. It's very, very similar to square root functions. A is going to dictate the stretch and also possibly the reflection. So if you put a negative out in front, it will reflect it, kind of like we did here. Like I said, this should have a negative out in front of the function. So the stretch or the reflection. H is going to be the horizontal shift. And k is going to be the vertical shift. The inflection point, that is going to be at h comma k. Find out h and k, you can get your inflection point. So based on this curve then, we can get a little bit of information from the function, right? So our goal here is to graph the function, describe the key characteristics, and we'll do that in a second. But just by looking at this, I can see that h is 1 and k is 3. So that means that my inflection point is going to be 1, comma 3. So I can go right to my graph and go 1 over 1 and up 3. There's where my inflection point is going to be. This is going to be reflected because of the negative. So instead of kind of going up from left to right like the parent function does, for example, it's going to look like this. It's going to go down from left to right. Right? So there's some things that we can get just by looking at the function here. So what we're going to do is we're going to take Desmos here and we're going to graph this function. So we'll type in -2 cubed root of x minus 1 plus 3. And so a little bit hard to see what's going on. There we go. So that's our graph, right? And we want to get a better sense of exactly what that graph looks like. So we'll turn this into a table. So I just hit settings and then tap the table. As you can see, I got this point 0, 5. That's on the graph, so I'll plot that. I have the point 1, comma 3. Yep, we've got that. That's our inflection point. We've got 2, comma 1, like that. And then, let's see, we can even keep going here. So if we get 3, okay, so then they become decimals, and they're not such nice numbers. But you can see we can get a pretty good picture of the graph here. Like that, okay? So the domain on this is going to be all real numbers. The range, all real numbers. Again, left and right forever, up and down forever. Last thing that we need then is the end behavior. So the end behavior is going to be as x approaches infinity. What are the y values doing? And sometimes the book uses f of x, so you should get comfortable with that too. So as we move to the right, f of x is going down, the y's are going down. So we say it's going to a negative infinity. And then as x goes to the left, f of x is going, so as we move to the left here, to negative infinity, the y's are going up. So that's going to positive infinity for the end behavior there. Sorry I didn't leave you much space. But that's really it for section 5, graphing cube root functions. When it asks for the key characteristics, that's what I'm looking for. I'm looking for domain, range, end behavior, and inflection point. If it specifically asks for something else, then add it in. But if it just says key characteristics, that's what I'm looking for. And that pretty much wraps up all of section 5.